I mean, that might happen, but not right now. So, what is an exterior angle? Make sure I got this there. Recording, yes. So if we have a triangle, right? Where's my thingy here? What is an exterior angle or external angle? So if we take one side of the triangle, everybody see this, and extend it out here, this angle right in here is called an exterior angle. Okay? So as it turns out, the measure of this angle is equal to the sum, add them up, of these two non-adjacent angles, okay? The two remote angles from it, okay? Whatever the measure of this angle is, you can add these two up, and that sum will be equal to that measure. Everybody got that? So let's think about why that is. And so they call these, I always call them the non-adjacent, right? Because, well, this one would be adjacent, you know what an adjacent angle is, right? Okay? And these are the non-adjacent or the remote angles, okay? So let's see if we can work out why that might be.
Shouldn't you just know what remote means?
You could, but oftentimes there's more than one term that refers to the same thing. I mean, like if you heard external and then in the homework they say remote angle, well, it's remote angle, right? Another one, okay? What's that? So it adds up to the other two. So let's think about why this might be, just real quick. What do all three angles in a triangle add to?
180.
Okay. What do these two angles add to?
180.
So this one here plus this one equals 180.
Yeah.
So, but this one plus these two equals 180 also, doesn't it?
Yeah.
So could we substitute the value of these two for that one? Since they all have to add up to 180? So just kind of a little preview as to why this one equals the sum of those two. Because there's two sets of things that have to add up to 180. Right? And one of them is common to both things. That makes sense, okay? Why is that? How did they get the isosceles thing down there? That's an error. This doesn't go here. So that's a symmetry proof of isosceles. We're on the external angles. Let's go to the next page. Anyway, so an informal proof, okay? So I better mark that. All right. So again, imagine you're sitting at your desk with a paper triangle, okay? And we're going to tear off a couple of corners here. So we have an external angle, right? And these all add to 180 degrees, all three of them, okay? And we tear off this corner and that corner, that angle, okay? And then we translate them, right? Let's translate them here. Translations are what? No. No. Yeah.
Isometric.
Rigid isometric, right? So they don't change their measurements when we move them into this little nook here, okay? We also know these two add to 180, don't they? Right? So if you tear these two off and place them in here, they fit perfectly, right? You see that? And so now, since these two add to 180, what do these three add to?
180.
180. And are these two not the ones that came from over here?
Is.
Okay? So that means that this, they're the same measure. That means that this external angle is equal to the sum of these two. Here's the sum. We tore off the sum and put it over here, didn't we? And you can see that it's equal to that external angle.
Yeah.
Because both things have to add to 180. These three angles have to add to 180, and these two angles have to add to 180. So we can use some substitution. Or maybe we could use transitivity, if you remember that, okay, to work that out. Well, let's go. Oh, am I recording? I'm recording the whole screen, okay? Whatever. It's still recording. I forgot to do that. But it'll look a little different. So here we go. Here's two-column proof. So what are we given? ABC, triangle ABC. With external angle, they call it angle 1. And then we also have an angle 2 here. They want us to prove that angle 1 is equal to the sum of angle B plus angle A. In other words, they want us to prove the exterior angle theorem. Okay? So let's think about how they go about this. They've got the given here. So here's what they say. Angle B plus A plus 2. Aren't those the triangle angles, right? This would be the triangle. Okay? Add to 180. You know that. We proved it earlier, didn't we? Okay? Triangle, and here's the reason we can say that. Triangle angles add to 180. So that's another reason you might use in a proof somewhere. Okay? It's valid. So now down here, they say angle 2 and 1 add to 180. Well, what kind of angles are these? What kind? Linear pair. And you know that they're what? Right? Okay? So these guys form a line, which means they also add to 180. Okay? Now, we have two sets of things here. Both this sum and that sum both add to what? They both equal what? 180. So this is transitivity, right? If A equals B and in turn B equals C, then what can you say? A equals C, doesn't it? Or we could think of it as substitution, right? So let's do some substitution here. If both of these things equal 180, what can I say about these two things on the left-hand side? They have to be equal to each other. If this adds to 180 and 1 and 2 here add to 180, then this and this have to be equal. Look what the next statement is. So everybody got that, right? Since these two sums both equal 180, don't these two sums then have to equal each other? Everybody with me? And so how did we get this statement here? What did we do?
Substitution.
We substituted equal things for equal things, didn't we? Which you can always do, okay? All right, so we can also think of it as transitivity. So remember I said before, they're almost interchangeable, substitution or transitivity, right? It's fine. So now, how do we get from this line right here to this line?
Go down a line.
Then a little bit more. What, okay, on both sides of these equal signs here, what do they have in common? Is there something that's the same on both sides?
And
Angle 2, measure of angle 2 is in both sides. So what can we do to both sides of this equation to simplify it?
Take out.
Subtract the measure of angle 2 from both sides, right? We can subtract that and that out from both sides of the equation. And what does that leave us with?
measurement 1.
So all we have here is
measurement B.
1?
plus Measurement A.
Yeah. So this is all we're left with. Is that not what they wanted us to prove?
That is the one.
And so this statement that we make here, what justifies it?
Subtraction.
Remember I showed the subtraction property of equality.
Yes.
Follow that?
Follow.
So remember, if you have equal things, they can be substituted for one another, right? And if you have something on the same side of the equation, both on the same side, you can subtract it out of both sides
Yes.
using properties of equality, okay? Down here then. So that was a formal proof. Let's look at a transformational proof, okay? So we're going to talk about translations, right? Well, after a translation, all corresponding sides are what?
Congruent.
And what?
Isometric.
Parallel. Yeah, that's what I'm getting. That's true. Translation.
I think I've gotten everything except the right answer so far.
Corresponding sides are congruent, but more importantly here, they're parallel. And what about corresponding angles after the translation? What are they? Congruent, okay? Remember, parallel, or translations give you parallel corresponding sides, one congruent, right? But parallel is important now. And congruent corresponding angles, okay? So here's how we're going to think of this. So we have this triangle here with an external angle, do we not? Okay? So what are we going to do here with this triangle? Well, actually, just this side. Actually, we're just going to do it with AB, okay? What are they doing here with AB? Translating it over there to A prime, B prime. Everybody with me? Which means then that these guys are what?
Congruent.
Parallel.
Congruent, and more importantly for this proof, they're parallel, okay? Now, do you know anything about parallel lines cut by, say, a transversal here?
Alternate interior.
That's one of them.
Alternate exterior,
Corresponding.
consecutive interior, consecutive exterior.
So look at these two angles.
B and C are corresponding.
They are B and, well, A prime C.
C,
B.
B prime.
Okay. These are corresponding angles and they're congruent, are they not? Now what about this angle and this angle?
Look, corresponding.
No, they're not corresponding.
Oh, wait,
What? Alternate interior. These are alternate interior. I thought you heard you say exterior.
Wait, so what is the transversal? The one segment AC? Yeah.
Now we're using that transversal with the same parallel lines. So look, so this angle's congruent to that one. Hey, that's like tearing the corner, right? Tearing that off the piece of paper and putting it there.
Yeah.
Is it congruent? And then it's like tearing this one off here and placing it there. So you can kind of connect how it's like the paper triangle one, right? Okay, so what does that tell us then? Right? So these are alternate, so we'll just say alternate interior angles congruent, right? So that just says whatever these two angles add up to, they end up over here after a translation, don't they?
Yeah.
Which means then that this here, this exterior angle right here is equal to the sum of those two non-adjacent interior angles, or remote angles.
Put together.
Yeah, the sum, that's what the sum is, right? You have two things, the sum is the two of them together. But you can also think of a sum as taking its amount and physically placing it in, right? Okay, whatever that sum is, you can move it into an equal spot. So, let's look at an example over here. So, determine the measure of angle BCD. That's this guy right here, BCD. That's the external angle, isn't it? Simple enough. We know now, we've proven it, so now we can use it, right? We've proven a theorem, which means now we can officially go and use it for something more practical. So, this angle has to be equal to what plus what?
A plus B.
Well, there are numbers there.
Right?
92 and 46, so this exterior angle is 138. Isn't that, that's easy, right? Okay? So why don't you guys take a minute, and I want you to work on these three here.
Already.
Okay? I'm going to call it angle 1 here. So measure, less writing. What'd you do? So I don't know. See, look at that. Oh. Well, that's it. I think I'm putting in my 2 weeks notice. 74. And what do we got?
Still got 20 years left.
Thanks, man.
No,
Well, that brightened my day.
no, oh Lordy, over 40. So he's over 40. No,
Okay?
he's maybe 70.
All right. How about B? Did you get it yet? That's a little different, isn't
I
it?
got 96.
No,
Not wrong.
What? How?
it's not 96.
You had 73 and 74.
We're in part B.
No.
Talking about problem B now.
16.
Nope, but thanks for playing. Anybody get B yet? What you got?
Wait a minute. I have a question.
What'd you get?
Got 19. Yes.
Okay, yeah, 44 for measure of angle B. Yeah, that's right, there's 2 parts. Let's call this, let's call that X.
65 by 20.
How about this?
That's not
I've actually done that.
Is that true? There's my exterior angle theorem algebraically, right? So what's X equal? And the other one they wanted was what? This one? Let's call that Y for BCA. Wouldn't Y plus 65 equal 180? So what does Y equal? Okay? And the last one, we're looking for angle A.
You could do that in a different way.
Now we'll shrink it. Sure, you can add those up and subtract, right, yeah. There's all kinds, there's more than one way to skin a bed. Sure. But remember, I want you to see a bunch of different ways to do things and be able to reconcile them all to see that the really was kind of the same.
Well, why would you want to skin the badger? Or eat it. Things are mean.
Can you eat it? You can sell it on eBay.
You need anything you want.
Well, I know, I'm just saying.
You can eat high fives.
How?
All right, hey,
Still, 1 to 10 in the power.
what's the measure of angle A? Say it again. How many got 118 for angle A? How'd you get that? Okay, so now you did the algebraically, I'm gonna do it another way now. I'm just gonna say, well, these two add up to 160, then I know 160 minus that one. And what was it? 118.
I did this a lot more than yesterday.
How about BCA? How are we gonna get BCA?
20 degrees.
That's 160. Okay?
Oh, that's great.
Or, once you had this as 118, you could just forget this thing here and you could do 180 minus 118 minus 42 and get 20, right? So there's all kinds of different ways to get at things a lot of times. Okay?
We're on region.
Yeah, okay, here we go. So we've proven some things about isosceles triangles, right? And we've proven some stuff about exterior angles. So all this stuff that you got to kind of have this, keep it in your memory banks, right? It's going to be useful to us. Okay? We've proven that triangles add to 180. All right, Regents questions. Let's take a moment and read this over. First one. I have a question for you here. You see where they ask this right here? Which value of x makes AB congruent to CB? Aren't they really asking the following? Which value of x makes the triangle what? Isosceles, two congruent legs. So you can see they ask it in a kind of an indirect way, right? They're really asking what value of x makes the triangle isosceles, because if they're going to be congruent, it's got to be isosceles. Follow that? Okay. So what do you guys say? You get one again?
118.
He says 118. Is he right?
I don't think so, to be honest. I think he's incorrect.
Yeah, they divide it. 118. Dang it. There you go.
She says 121.
Oh, wait, no, that's.
It's none of them, okay?
That's what
118.
Just let me finish it up.
Guys, if these two sides are congruent, what do you know about these two base angles?
59.
Well, they're congruent,
It's
right?
118 divided by 2. I know that. I'm just kidding. I'm like, I'm slower.
It's 59.
Yeah, which is 118 divided by 2.
I said what value? X.
I know, but did you do it right the whole thing out?
No, but it says value of X.
Oh,
so you
yeah.
split the two.
I was right.
No, which value?
Why would we split x?
It says what value is X?
What value of X?
So
So
it's
wouldn't it be 118 because it's those two?
It is 118. Question asked.
All right,
What's
pause.
59.
Yes.
Exactly.
Listen.
That's why I'm right, yeah.
If I could find the measure of this angle here, y, then we know that these two add to,
Okay.
okay, how are we going to get y? Right?
Yeah.
We do it algebraically. What is that? So what is the measure of angle y?
I know, but I'm confused because they don't tell us to find the value of those two.
But you
Yeah,
just have
but you
to.
I'm not going to. You have to know that.
Yeah, you did.
You need to know that you need those two.
Fine.
That's why you're here in this class.
So
See?
if I don't get a lesson, I understand.
Yeah, same.
So 59 degrees here. So now x plus 59 has to add to what? It's just a straight line. What's x equal? There you go.
That makes the size so wrong.
Yeah, I thought it was 118.
Well, do you follow how we got it?
Yeah.
Okay.
Okay.
Yeah, they're not gonna tell you, well, we want you to find X, but first you need to find the they're not gonna tell you all the steps involved in it, right? Because then it'd be like reteaching the whole lesson again, or assuming you know. Does that make sense? Okay.
I like that answer, but I didn't want to believe it.
Well, again, have the confidence to get an answer, stand by it, and believe it. Yes, sir. Yes. All right, let's work on this second one here. So this is one where you'll kind of want to try out all the choices till it works, okay? Thinking about what we just learned.
I'll put my light on.
Well, okay, what's your life on? What'd you say?
4.
4. All right, he just bet his life on choice 4. Is he right or wrong?
Can I kill him if he's wrong?
Eh, sure. Just do it out there.
I want him to go with that.
Did anyone else get choice 4?
I didn't
Couple
know
of-
what I was doing.
Couple of citizens here. Well, let's take a look at the choices. So they're saying here that angle 1 equals angle 3 and 2. So 1 equaling 3 and 2. Is that something we learned?
No.
Oh.
If it was 3 and
I mean,
4.
it's kind of getting close to exterior angle theorem, but it's not, right? How about angle 5 equaling 3 minus 2? It just seems like nonsense. I don't even know where that would come from, right? Okay. How about angle 6 equaling 3 minus 2? That's just more nonsense.
Yeah, it is more nonsense. So.
Right.
I
But
think-
angle 7
No, that's not nonsense.
here
I
equaling the sum of these two
We can't kill him.
remote angles. Hey,
It's free.
is this not exactly the exterior angle theorem right here? Choice 4.
Yep.
And there you go.
That's the only problem I've been
Okay.
sure of my life.